The area of one face of a cube is 16 centimeters squared. The volume of the same cube is V centimeters cubed. What is the value of V? So if we have a cube, then they're saying if the side is X, then they're saying that the area of one face is 16. So that means X squared is 16, and therefore X would be 4. Now the volume of that cube would be X to the power 3. And since X is 4, that would be 4 to the power 3, and that is 64. So V is equal to 64. In the diagram, point D is on side BC of triangle ABC. If BD is equal to CD is equal to AD, and angle ACD is 40 degrees, what is the measure of BAC? So this is what we call angle chasing, and here we go. So this is the same as that, so therefore this angle is the same as that angle, so that's 40 degrees. And that angle, therefore, would be 180 minus 40 minus 40, right? Since the angles all have to add up to 180. So that basically means that that's 100. And then this angle is going to be 180 minus 100, since those two angles have to add up to 180. And then therefore this angle, which I'll call theta, is the same as this angle because these two sides are the same. And therefore in that triangle, the theta plus the 80 have to add up to 180. So therefore 2 theta is 100, and therefore theta is 50. So if theta is 50, then that whole angle, which is what BAC is, so angle BAC is theta plus 40, and since theta is 50, that's 50 plus 40, and therefore that's 90 degrees. Marie Pascal solves 4 math problems per day. Cayley solves X math problems per day. Over a number of days, Marie Pascal solves a total of 72 problems. Over the same number of days, Cayley solves 54 more problems than Marie Pascal. What is the value of X? So 72 over 4 is 18 days. So that's the number of days. And then for the other person, 72 plus 54 is the number of math problems, and we divide by the same number of days. I'm assuming over a number of days, the same number of days. Okay, that's why we divide by 18. So then this math is 126 over 18, and that is 7. So X is equal to 7. If A, B, C, and D satisfy over B equals 2 over 3, and C over B equals 1 over 5, and C over D equals 7 over 15, what is the value of AB over CD? Okay. All right, so let's see, where do I go with this here? If I cross multiply, I get 3A is equal to 2B from the first one. From the second one, I get 5C is equal to B, and this one gives me 7D is equal to 15C. Correct? So D would be equal to 15C over 7. B is 5C. I'm trying to get everything in terms of one letter. So if D in terms of C, C is already C. B is in terms of C. If I can get A in terms of C, that would help me. So let's see if I can do that. First, let me get A in terms of B, and then I'll substitute that. So 2 over 3 times 5C. So that'd be 10C over 3. Okay. I think I got everything in terms of C, so now let's calculate that guy. So AB over CD. So that's going to be A, which is 10C over 3, times B, which is 5C, over C times D, which is 15C over 7. So all the C's cancel, right? Because it'd be C squared on the top, C squared on the bottom, so the C's would cancel. And then the numbers would be 50 over 3 and 15 over 7. So that's going to be 50 over 3, invert and multiply, 7 over 15. And let's see here. That is, what is that? 350 over 45. And I think we can divide by 5, top and bottom, so it'd be 70 over 9. 70 over 9 is the answer. Magnus and Viswanathan play a game against each other 3 times. And I encourage you to read the rules. And they're asking what is Magnus's score in the 3rd game. So after you read the rules and understood it, hopefully you can follow along the solution. So we have Viswanathan and Magnus, and we'll have the first game, the second game, and the third game. So we know that Viswanathan wins one of the games, right? I don't know which one. Is it the first one or the second one? But they say it's one of them. So let's try that he wins the first game. And let's see what happens. If it works, great. If it doesn't, then we can try something else. Now, we are told that his score is 25, right? He wins the third game with a score of 25. So put 25 in there. And he wins either the first game or the second game. So we're not sure which one, so that's why I put first. And then if that doesn't work, I'll try the second game. And then we are told that the average, each player's score in the second game is the average of their scores in the first and third game. So, for example, whatever goes in here is going to be the average of the first game and the third game. So you can sort of say, if this is 25 plus 2d, then this would be 25 plus d. And you can see that works out. Say if I add 25 plus 2d plus 25 and divide by 2, it'll be 25 plus d. So that's why this will be 25 plus d. Okay, so let's see what happens. Now, for Magnus, his scores that we need to figure out. Right here, if the winner's score is greater than 25, the opponent's score must be exactly 2 less. So since this is greater than 25, this will be 2 less. So this will be 23 plus 2d. Just according to what they're saying. And then in this game, since this is also... and the second game, Viswanathan loses, right? That's how we're choosing it. So we have to make this a winner. So therefore, this has to be, for Magnus, 2 greater, since he's the winner. So it'd be 27 plus d. And then therefore this one, t, is the average. Well, t plus the first game divided by 2 gives me the score for the second game. So this would be t plus 23 plus 2d is 54 plus d. And therefore, let's see here. Let me see if I did this right. 2d actually. And then therefore t would be 31. Okay, so t equals 31. But here's the thing. That's not possible because they've even said that the winner's score, if the winner's score is 25, the opponent's score must be at most 23. So since this is 25, t has to be at most 23. So t equals 31 is not possible. So you can explain that, not possible. Okay, so that's not a problem. It just means that it's not the first game that Viswanathan wins. He wins the second game. So let's do this whole thing again. But this time, we make him win the second game. So we get the first game, second game, and third game. So the same story all over again. But we are now choosing the second game for him to win. So let's do that. So there you go. We'll put a W there. And then let's see what happens. Okay. So now, same kind of story. This is still 25. And the 25 plus 2d, that pretty much will be the same. Now we say, if he wins that means what was his name? Magnus? Magnus. He loses the second game, so he's going to have 2 less. So it's 23 plus d. And since Viswanathan wins only the second game, that means he loses the first game, so Magnus wins the first game. So if Magnus wins, then he must have had 2 more. So in terms of his score, so that's 27 plus 2d. Okay, so then again, let's calculate t. So t plus 27 plus 2d over 2 is 23 plus d. So that means t plus 27 plus 2d is equal to 46 plus 2d, and therefore t is equal to 19. And that satisfies the criteria that If the winner's score is 25, their opponent's score must be at most 23. So therefore, since we have satisfied it, t equals 19, or 19 is the answer to the question. How many ways are there to choose integers a, b, and c with a less than b less than c from the list so that the product abc is a multiple of 12? So we want 3 digits that when you multiply them together, it's going to be 12 times something, a multiple of 12. Now 12 itself is 2 times 2 times 3. So the 3 integers that we choose have to have a combination of a 2, and a 3. So let's see what we can do here. Now these numbers that they gave us, let's put them into little groups here. So first we have a group that has none of those. It doesn't have any no factor of 2 or 3. So that's these guys. I think 1, 5, and 37. So let me just circle them, 1, 5, and 37. Then we need a number that is divisible by 2, because that's going to give me these guys. So those are all the even ones at 2, 22, 46, and 50. 22, 46, and 50. But there's a 8 in there, but 8 is a little bit different because 8 is divisible by 4. So that 8 would give me both 2 times 2. You see what I mean? So it's a slightly different category. Then, of course, we have to look which ones are divisible by 3 so we can get 3. And I believe, well, let me circle the 8. We got 21, 27, 33, and 39. And then this 30 is interesting because the 30 is divisible by both 2 and 3. So that's why it's sort of in its own separate category. Okay, so we've grouped all the numbers into categories. And now let's see what are the scenarios to create ABC. And let me think about this. So I think, let me make a little table here. Yeah, I think I should be able to do it in one screen, hopefully. Okay, so here we go. The first one involves the 30. We gotta choose that because that has both 2 and 3. So if I have A, B, C, 3 numbers, and I choose 30 as one of the numbers, so I've already got a factor of 2 and I've already got a factor of 3. Remember, I've got to have 2 times 2 times 3 to get a 12, to get a factor of 12. So the 30 already gives me the 2 and the 3. So I have pretty much, the only thing I need to get is a factor of 2. So I have to get a factor of 2 from that guy. Yeah. And then I think that's it. So numbers that give a factor of 2 are the 22. Let me just write it down here. 22, the 46, the 50, and the 8. So for this guy here. So that's 4 possibilities. And then for this number here, well, at that point, it doesn't really matter. We can put anything we want. So if we put another one of those guys from that same list, then that would be 4 times 3. Because we have 3 possibilities remaining. Because it has three distinct numbers, right? Yeah, because they're separate. So, but you have to remember, you have to divide by 2 to give 6, because it would be the same if we would double count, basically. So for example, those 2 numbers could be 8 and 22, 8 and 46, 8 and 50, 22 and 46, 22 and 50, and then finally 46 and 50. So that's why you see those are the 6 combinations. So we have 6 ways of making it like that. Okay, that's pretty good. So let's move on. The next way is another 2, 2, 3. Well, we always need 2, 2, 3, so I don't really need to write it every time. But again, we're going to use 30 as the first number, but the second number, I'm going to, again, choose some factor of 2, some number that has divisibility by 2. So that's going to be the same kind of guys, 8, 22, 46, or 50. So there's 4 of those. But for the third number, I'm going to put, at this point, since I've covered my bases, I've already got the 2, 2, and the 3. I can put anything else. So for here, I'm going to put an odd number. So the odd numbers are 1, 5, 37, 21, 27, 33, and 39. So there's 7 of those guys. So 4 times 7, that's 28. So 28 numbers that are created with that kind of strategy. So now we got 28. Okay, let's move right along here. Now we got another scenario. So we're done with the 30s. So the 30s are exhausted, so we're done with the 30. The next scenario is if we have a factor of 3, and then a factor of 4, and then a factor of 2. Yeah. 3, 4, and 2. So let me explain. So the first one, that is a factor of 3. How many numbers are a factor of 3 here? 4 of them, right? These guys. The 21, the 27, the 33, and the 39. So there's 4 numbers that have a factor of 3, divisible by 3. And then the next one, we need a number that's divisible by 8. And there's only one of those guys. It's just the 8. So there's only one of those guys. And then a number that's divisible by 2, only 2. There's 3 of those guys, 22, 46, and 50. So 3. So then 4 times 1 times 3, that's 12. So we'll create 12 numbers using that strategy. The next one would be a 3, 3, 4 strategy. So we want 2 numbers that both have a factor of 3. So we're going to be choosing from these guys, right? Yeah. So that's going to be these 2 numbers here. There could be either 21 and 27, 21 and 33, 21 and 39, 27 and 33, 27 and 39, or 33 and 39. So there are 6 of those. So we've got these 2 will be 6. And then a number that's divisible by 4, well, there's only one of those, and that's the 8. So there's only one. So 6 times 1 is 6. So 6 numbers that fit that criteria. The next one will be a 3, 3, 2, 2 scenario. So the numbers that are divisible by 3, there's 21, 27, 33, and 39. So there's 4 of those guys. And then the numbers that are divisible by 2, let's see here. We want 2 numbers. 2 numbers, so from this one. So we can have 2240, 2246, 2250, or 4650. So that'll be 3 choices for these guys. So 4 times 3, that's going to be 12. So 12 of that nature. And then I think the last one is a scenario where you have a 3, a 4, and then this guy can be one of the other ones, an odd number. So for the 3, we've got 21, 27, 33, and 39. So there's 4 of those guys. For the 4, there's only the 8, so one of those guys. And then the odd, these are the odd ones. Where are the odd ones here? These ones up here. So 1, 5, and 37. So 3 of those guys. So 4 times 1 times 3 is 12. So we have 12 of those guys. And I think this exhausts it. So our total would be this 6, this 28, this 6, this 12, this 12, and that 12. And when you add those up, you get 76.